Good day, students. This will be a lesson talking about seafloor spreading. Please take notes along with me. If you need to pause or rewind, you're welcome to at any point. So to start with, we're going to talk about seafloor spreading. And seafloor spreading really this idea started to come about in the early 1900s. And the reason behind this is we had new technology that was developing called the echo sounder. And how this echo sounder, what it allowed us to do was to map and to find out the depths of the ocean floor. So map the ocean floor by depth. Prior to this, we would have to use, they would take a rope and an anchor and they would drop it until it reached the ocean floor. They would pull it up and they'd measure how much rope it was to the surface. And they would do this every so far off to start to map. Very slow, time-consuming process. So what they found with the echolocator, and you can see down here in the diagram with the boat, is just like echolocation, is it would send a signal, it would hit the rock bottom, and then that signal would come back up, and what they would do is they'd measure how long that took. And it's kind of like a fish finder, those kind of ideas, to give you that basis of what the ocean floor looked like. One of the things that they found is that the ocean isn't flat. And it actually has mountain ranges, it has valleys, it has quite the variety to it. One of the things that we're going to talk about is the mid-ocean ridge. And the mid-ocean ridge, which I'm going to refer to as the MOR through the rest of our lesson, is an area that is really what it is. It's an underwater mountain range. And this is really where we're going to focus on talking about seafloor spreading. So after the 1940s, they continued to do some developing that way, but it wasn't really until back into the 1960s that we start to see this idea of the actual kind of theory of seafloor spreading being developed. And I'm just going to make my text a little smaller here so that there's a little bit of room. But what we started to see is that new ocean floor was forming at the mid-ocean ridge. So at the MOR, new ocean floor was created. And it was created by cooling of magma. We'd see that magma would come up through that crack and would start to form new rock. Fix my spelling here. Cooling magma. What we can see is that the newest rock is found at the mid-ocean ridge, where as you get farther and farther away from the mid-ocean ridge, it becomes older and older rock. Because what happens is the new rock pushes the old rock out. So again, we kind of get to see that the mid-ocean ridge, which is right here in the middle of this diagram, this is where the newest rock is formed, and then as it gets pushed out, we will see older and older rock form. Let's talk about two ways that we can see the new ocean floor form. So one way that it can form is new ocean floor is going to be created when we see the magma rise to the mid-ocean ridge. So new ocean floor is created at the MOR. The second way that we can see that this is formed, I'm just going to make my font a little smaller so you guys are able to continue to see it. And the second method is we will see magma pushes through cracks in the ocean floor, and this tends to create more mountain ranges. So two different ways. It can come up through the mid-ocean ridge, or it can actually come through different cracks in that are found already in the ocean floor to create new mountain ridges. One other main feature that we want to talk about is the abyssal plain. In the abyssal plain, how this forms on the ocean floor, and it is the flat area of the ocean floor. So the abyssal plain is the flat portion of ocean floor. And this occurs when enough sediment, enough material accumulates in that new ocean floor that causes it to become thicker and it causes it to flatten out. So it's created by layers of sediment. Layers of sediment that causes the new ocean floor to become thicker. So as, let me see if I can get rid of my, there we go, so you can see this. Abyssal plain, flat portion of the ocean floor created by layers of sediment that causes the new ocean floor to become thicker. So as it leaves the mid-ocean ridge, we can see that as more material builds and puts pressure on it, it starts to flatten out. So that creates this kind of abyssal plain. So we'll have by the mid-ocean ridge kind of mountain ranges, and then it will start to smooth out. So we've talked about the idea of seafloor spreading, but how do we know that it actually exists? What are some evidence of it? And one of the key things that we can look at for evidence of seafloor spreading is the parallel bands of magnetic rock. So they started to notice that there's these varying bands of rock, and they're not actually striped like that looks like in this diagram, but they have different types of magnetic polarity. And we have two different types. We have normal and reverse. And normal would be kind of what we think of right now. If you look at this diagram up here on the left, it's showing that our north pole is also the same as our north magnetic pole. There has been times, though, in history throughout geological time that our magnetic pole has actually flip-flopped. So maybe what we would refer to as the North Pole would actually be the magnetic South Pole. So it kind of flips. And what they can do is they can see that within the rocks, these parallel bands, meaning that on each side they're equal bands, they can see that normal or reverse, and it flips so many times throughout history. And the reason they can see that magnetic properties is due to minerals that are found within the rocks. So a lot of these rocks are very rich in iron and stuff that's magnetic, and so we can actually see the reverse of this kind of polarity. So over time, we have another image showing over millions of years. We have the magma that rises, comes out of the mid-ocean ridge. So this is the newest rock. It will be pushed outward. And as this rock forms, over time, it gets pushed outward. And we will see that the polarity will reverse. So we might have normal, we might have reversed, and so on. Two other points to make about evidence of seafloor spreading, we're just going to add right to this, is that we've actually been able to look at the age of the rocks, and we see that the newest rocks form at the mid-ocean ridge, and older rocks are found farther out. We also can look at the thermal energy, and we can see that there's less energy or less heat in rocks as they get older and older, get farther and farther away from the mid-ocean ridge. So we're able to see that there's less energy that's being formed in here, and the fact that as it leaves the mid-ocean ridge, it cools. And the reason we know that this is occurring and that it's an equal thing is that we can see similar results on both sides of the mid-ocean ridge. So, just to kind of recap some ideas here, seafloor spreading is the growth and development of new ocean floor. It is thought that this ocean floor is created at what we call the mid-ocean ridges, which is the place that opens up in the crust of the earth and allows for magma to come up. As the magma comes up, it cools and forms new ocean ridge. Evidence of seafloor spreading are magnetic bands that are found on the rock, and the fact that the age of the rocks are equal to each other on each side of the mid-ocean ridge. And we see the newest rock is closest to mid-ocean ridge, and the oldest rock is farther up. We also can see that there's less energy in the rocks as they become older and older. To end this lesson, what I would like you to do to prepare for tomorrow's activity is I would like you to look at the skill lab on page 509. Again, that page is 509. And I would like you to answer, you're going to look at the Apply It section and go to number 6. It says, compare the map and the model. Where is the Mid-Atlantic Ridge on the map? Where is it represented in your model? So you haven't developed a model yet, but I would like you to answer that first part of your question in your notebook so that I know that you are ready to go. And what I would like you to do is tell me, looking at this map, where would the Mid-Atlantic Ridge be found? Thank you for listening. Again, if you have any questions, you're welcome to repeat this or bring them up in class and we can further discuss. Have a wonderful day.